So evaluate logarithm and change of base theorem. So the first thing we're going to start evaluating logarithm. Let's start with the first rule. The first rule always, if you have, and also you can see that in the calculator, this is the first rule. If you have log to the base 10, to the base 10 to the x, you can use, instead of log to the base 10, always, if there's a base 10, that means you're just gonna say log to the x without typing the base 10. So if you check, or the opposite thing, if you see log to the x, that means the base is 10. Even if you check the calculator, you will see exactly the same thing. There is a log here by itself without base. When you press this one, it's going to be log by itself. That means the base here is already 10. So let's try to do an example. So if you have log to the 1,000, that means it's already, the base here is 10. So it's already log to the base 10 to the 1,000. So it's up to you. You can plug this one if you want to use the log to the base. If you want to use the log to the without base by just clicking on this log here in the calculator, is going to be the same result. So if you type 1,000 here, close the parentheses, is going to be the result 3. And also, if you want to use the log to the base, math, so scroll down, log to the base, you have to submit the base 10 and the 1,000 here is going to be exactly the same result, which is 3. So it's up to you which one you're going to use. Both is going to be right. That's only if there is no base. If you can't see a base here, that means the base is 10. So it's up to you which one you're going to use is going to be right. Here's another example. If they're telling you find log to the base, there's no base, 142. So it's up to you. There's no base here. That means it's log to the base 10, 142. So if you want to use the calculator by finding, just click on the log, 142, close the parentheses, is going to be 2.15. 2.15, let's say 229. I'm just going to take 3 numbers. 229. If you want to use the log with the base, you're going to press on math, scroll down to log to the base. You have to plug in the base is 10, and the number here is 142. The result is going to be exactly the same result here. So I'm also going to round it to 229. So both way is going to be right. If they ask you to find log, here's another example. Log, there is no base, but 4.43 times 10 squared. They ask you to find log to this number. So now it's up to you also. You want to use, there is no base here. That means the base is 10. So instead of using the base 10, I'm just going to use the log. There is 2 methods to solve this one. The first thing, log to this number, you can just plug in the calculator, log and everything here, times 10 squared. Check how I'm going to plug in is going to be equal. I'm going to plug in just the log. Check here how I'm going to plug in. Type it exactly the same thing. So log 4.43 times 10 to the exponent 2. Close the parentheses. I have to close the big parentheses. So it's going to be 2.6464. So it's going to be 2.6464. So this is the first method by plugging using the calculator. There is another method about solving this one. Let's do it here, which is the math. This is using the calculator. I'm not going to say, no, don't use calculator. It's fine. The main thing, you have to know how to plug in the number. The second method, I'm going to say log 4.43 times, let's say times, not like this, 10 squared. This is exactly, if you remember yesterday, we took a rule. If you have log multiplication between two numbers, if you have log x times y to the base a is going to be log to the base a x plus log to the base a y. If you have multiplication between two numbers with a certain base, you can convert the multiplication to log x plus log y. I'm going to use exactly the same rule here. I'm going to say this is going to be equal log. The base is 10. I don't have to worry about the base. 4.43 plus log 10 to the exponent 2. Now this part, I'm just going to plug in the calculator. It's fine. I'm not going to do anything here with this part. Log 4.43 plus, there is another rule, we took it yesterday. It says, if you have log to the base a x to the exponent r, we're just going to move the exponents here. So it's going to be r log to the base a to the x. So I'm going to use this rule here on this part. I have exponents. So I'm going to move the exponents in the front here. So it's going to be 2 log to the 10. Now, if you plug in this one plus 2 times this one in the calculator, it's going to be the same result. It's going to be log, let's do it here, log 4.43, close the parentheses, plus 2 log 10, close the parentheses. It's going to be exactly the same result here. 2 point, let's find how much is going to be for this one. For the first one, log to 4.43 is going to be 0.64640 plus 2 log 10 is going to be 1. Add these two numbers is going to be 2.6464. So exactly the same result. This is the math way without using calculator. This is if you want to use the calculator. So both ways is going to be fine. I just want to show you, you will get exactly the same result, but the calculator, it's work exactly the same thing. But like the difference, you're going to save time here. You're not going to save time here. You're just going to do 3 steps, but this is how you're going to use the math. Let's do another example, exactly the same way. So evaluate log to 657 minus log 203. So this one is easy. You don't have to worry about this one. You're just gonna plug it in the calculator and just make sure, keep in your mind The base for this one is also 10. The base here is 10, so it's up to you which formula you're going to use. You can use the one without the log. You can say log 657, close the parentheses, close the parentheses. This is really important. Here's another note. Sometimes when you plug it in the calculator, you see, when you press the log, it's already open two parentheses. So 657, the first number, close the parentheses before you move into the minus. Minus, press the log again, you see another two parentheses, 203, close the parentheses. If you're not closing this parentheses, your result is going to be wrong. So check how much is going to be 0.5, 0.5110, let's say 7.
I have a question.
Okay, go ahead.
How many numbers are we supposed to put? Or
okay, they're gonna tell you. Like, for example, they're gonna tell you for this one, round to 4 decimal places. Okay? For, let's say, this number, if they ask you to round to 4 decimal places, I'm gonna write down the whole number here. Let's go to the question. 100693316. If they ask you to round to 4 decimal places, okay? That means it's going to be 0.511234. I'm gonna cut the number until here. So it's going to be 10. But when you cut the number here, here's 6, greater than 5. So I'm going to add 1 here. So the result is going to be here. Like we're going to round the number, okay? Let's do all the examples to 4 places. So you can understand 4 decimal places. Let's do a fast review here. Like if you get the result 0.5100321, for example, and if they ask you to round to 4 decimal places. So here is the result is going to be 0.510, 4 decimal places, 1, 2, 3, 4. That means you're gonna cut here. Check the number here. The number here is less than 5. So if it's less than 5, you're not going to add 1 to the other number. So the result is going to be like this. The same number, if you have 0.5100, let's say 521, and they ask you to round to 4 decimal places. So it's going to be 0.510, because I'm going to cut the number here. This number is greater than or equal to the 5. If it's greater than or equal to the 5, you're going to add 1 here. So 1 plus 0 is going to be 1. So the result is going to be this one. Okay? This is about how to round the number, because it's important. They're going to ask you to round the number. Let's the first thing write down the formula about how to find the pH. So the pH, if your major is nursing or we're going to take chemistry class, you will use this formula a lot. So here's the formula. It says pH equal negative log H3O. This is really important because they're going to ask you, this is the second formula, they're going to ask you to find the pH or to find the H3O. H3O is like, you already know the Hungarian. So H3O is like, they're going to give you how much the H3O, or they're going to give you the pH, and you need to find, so what they ask you to find. So first, here's the formula, pH equal negative log H3O. And there is a small plus here, it doesn't affect anything. not here. It's with the H3O. So don't worry about this plus. Now let's start doing an example. For example, this is a really important example. Example 5 in the workbook. They ask you find pH if H3O equal 5.8 times 10 to the negative 10. So they ask you to find pH and they're going to give you H3O. So I'm just going to use the formula. Even on the test, they're going to give you the formula. Go ahead, use this formula. So I'm going to write down the formula pH equal negative log H3O. So I'm going to give you the pH is going to be equal negative log H3O, which is 5.8 times 10 to the negative 10. This is equal. pH is going to be equal. Now we're just going to use the calculator, so don't confuse yourself. It's already formula. You're just going to write down the formula. The main thing I know, like 50% of the students, they do this mistakes. When you use the calculator, just be careful. Be careful when you open parentheses, because in the calculator, it's already there is parentheses. So be careful here when you plug in using the calculator. Check. There is negative here. Don't forget this negative sign. Don't press minus, press the negative. Do not press the minus. Press this negative sign here. So here is negative log. You see, it's already there's two parentheses. So I'm going to write down these two numbers, 5.8 times, you see, this is the point, this is times 10 to the exponent negative 10. And you see, I have to close the parentheses. So here's the thing, be careful when using the calculator. I don't know how you can see it or no. Log, here's the negative sign, log 5.8 times 10 to the negative 10. Even when you close the parentheses, make sure, because you write down the exponents, if you press parentheses, you see the parentheses is going to be here. Make sure to go down and close the parentheses. So now the result is going to be 9.23. 9.23. 9.2365. With this example, example 5 in the workbook, they ask you to round to the nearest tenth. Let's write down here, round to nearest tenth. Tenth, that means you're going to take one digit out of one number after the decimal here. So the pH is going to be 9.2. That means I'm going to cut the number here. The 3 is less than 5. So I'm not going to add number here. So the result is going to be 9.2. Because round to the nearest tenth. So one number or one digit after the decimal. But I'm going to check the second number. If it's greater than or equal 5, you have to add 1 here. If it's less than 5, you're not going to add number here. So the result is going to be 9.2. Now, example 6 in the workbook, which is also important. They're telling you find H3O if sorry, pH equal 10. Number 6, if pH equal 10. So you see, they're gonna ask you now. They ask you to find H3O if pH equal 10. we're going to use exactly the same formula. pH equal negative log H3O. pH equal 10. So 10 is going to be equal negative log H3O. Here's the thing. Next step, there is a negative sign here. That means there is -1 here. So I'm going to divide both sides by -1. There's invisible -1 here. The one here, divide both sides by -1. So on this side is going to be -10 equal, cancel the negative here, is going to be log H3O. Now, here's the important part. So if there is no base, that means the base here is 10. So I'm going to say it's -10 log to the base 10 H3O. Okay. Now who's gonna tell me the next step? If there is no base, that means the base is 10, because the rule says log to the base 10 for x equal the same thing log just to the x. So I don't have to type the base. That's why I use the 10 here. Now who's going to tell me the next step? The log form. We can't use the log form until converted to the exponential form. How? By moving the base here to the other side. So when I move the base to the other side, I'm going to cancel the log. The leftover here is the x, and the other side is going to be a to the y. So this one is written like this: y equal log to the base a to the x, which is the same thing here. Y is -10, log to the base 10, and here's the x. The x is H3O. So what I'm going to do here, I'm just going to move the base here to the other side, cancel the log. So it's going to be a to the y equal x. That's what I'm going to do here. So move, convert this one the log form. I'm just going to convert it to the exponential form, move the base, cancel the log. So it's going to be 10 to the -10 equal H3O. So I'm going to write down 1 times 10 to the -10. That's it. This is the result. Who tell me I'm going to move the base? Patricia, right?
Yeah.
Yes. I'm going to give you 50 points. Down this example. They said the population growth of an animal species is described by this formula. This is the important part. So I'm going to take everything here and write down f to the t equal 400 log 2t plus 3. This is the first step. When you see examples like this, they're telling you the population of growth of animal species is described by this formula. I'm going to take the formula here. This is the first step. Where t is measured in month, find the population of this species in area 6 months. They're telling you the t measured in month. That means they're telling you this t is the month. So now we need to find the population of the species in the area 6 months. That means t equals 6. So I'm going to plug in 6 here. F to the 6 is going to be equal 400 log 2 times 6 plus 3. That's it. Here's the 2 steps. And it's going to be the result here. We're going to use the calculator. Again, be careful when you plug in using the calculator. Do not do mistakes here. A plug-in, exactly, here's the formula. I put 400 log 2 parentheses, because there is large parentheses, 2 times 6 plus 3. So I'm going to plug in exactly the same thing. You see, 400 log, let's open already 2 parentheses. I hope you can see it. I'm going to type 2 times 6 plus 3. Close the parentheses. The result is going to be this one. 470. If they didn't ask you to round to the number, so just write down 470. That's it. I don't have to write down the result because they didn't ask me to round the number to a certain decimal. So that's it for this example. So you see, you don't have to get 0 on this example. They're telling you, here's the formula, put down the formula. Just you have, here's the variable here, t. The rest is the number. 400 log is a function, 2 times t. They're telling you t is equal 6, so you're just going to plug in 6 here. And the next example, you're going to plug in everything in the calculator. So f to the 6 is going to be 470. That's it for this example. So let's do it here, the natural logarithm and how it looks like. So natural logarithm, and what's the meaning of natural logarithm? Which is ln. This is the natural logarithm, ln. So now, the natural logarithm, ln to the x, it's a log. So it's the same thing. It's a log, but with exponential base to the x. If you check the calculator, there is a small e always, which is also the exponential fraction. Let's see, where is the e here? E by itself. Can I find it? It's supposed to be here. With the ln, there is e to the x, but always there is e by itself, which is the exponential function. E to the x, that's mean the exponential function for any x. So the natural log, the ln, it's a log with the exponential base to the x. So instead of using this one, if you have base e, we're going to use the ln to the x, which is exactly like the same log. It's a log, but with the exponential base. So all the rules for the logarithm, you can use it on the natural log. So the first rule, we can find it from here. We can say ln to the xy, x times y, is going to be ln to the x plus ln to the y. It's exactly the same thing. You can say ln x plus ln y. The second rule, ln x divided by y is going to be ln x minus ln y. So it's a ln. Even if you check the calculator, there is ln. If you see there's a log function here, there's another function that says ln here, which is the natural log. So instead of using the log, you can use the ln. It depends about if they give you ln, I'm going to go ahead and use the ln here. It exists here. The third rule, you can use it when we have natural log. If you have ln x to the exponent r, we're going to use exactly the same thing, moving the exponents in the front. So it's going to be r ln to the x. So here's everything about the ln, the natural log. So we're going to use this a lot. Exactly the same rule for the log is going to be on the ln, and we will see next example. So next example, if you have the same thing, log, not log, now we have len, a natural log. So len, they ask you find len 815 times 34. So you don't have to confuse yourself. It's already, you can use the calculator, or you can use one of these rules. One of these rules, if you have len to multiplication between two numbers, you can say len to the first number plus len to the second number. So you have two options to find the solution for this example. You can just plug in the calculator, len to multiplication between these two numbers. So I'm going to press len. You see the difference between these two functions. Now we have len, ln, parentheses, I'm going to say 815 times 34, close the parentheses. The result is going to be 10.22. 10.22. I'm going to write it down 2295. 2295. Okay. 4 decimal places. Or you're going to use one of these rules. You're going to say len 815 times 34 is going to be len to the first number, which is 815, plus len to the second number, 34, and it's going to be exactly the same result. Len 815, let's find it here, len 815, then 815 is going to be 6.7318 plus len 34, len 34, close the parentheses, is going to be 3.5263, then 636. Then add these two numbers, is going to be exactly the same result, 10.2295, and keep going. They ask you, it's 4 decimal places, so it's going to be exactly the same result. So it's up to you. If they tell you find len 815 times 34, you can just plug it in the calculator, or you can use the rule. The same thing if you have len 93 divided by 23. If you want to use the calculator, so just len 93 divided by 23, close the parentheses, is going to be 1.3971. 1.3971. Or if you want to use the calculator, sorry, if you want to use the rule, len 93 over 23 is going to be len 93 minus len 23. Now we're just gonna find len 93, 4.5325 minus len 23, 3.13541359 minus these two numbers is going to be 1.3971. Both way is going to be right for this type of examples. This example, do not confuse yourself. If you got example like this, only we're gonna solve it in 2 steps. So don't lose these points. It's 2 steps, only 2 steps. So check how we're going to solve it. The first thing, they ask you the logarithm function, this one, which is this one is the important thing. Here is the function. So here is the first step. I'm going to write down f of x equal -100 plus 86 ln x. This is the first step. Now let's see what they're telling me, which is models the number of visitors in million to a certain country museum. Where x is, that's why they're telling you what is x. X is the number of years since the initial recording of the numbers of the visitors. Use the function to estimate the number of visitors in year 50. That means they're telling you x equal 50. So now I'm going to do the second step. F to the 50 is going to be equal -100 plus 86 ln 50. F to the 50 is going to be equal. Now I'm going to plug in this one in the calculator. So I'm just going to say negative, this is the negative sign, not the minus, -100 plus 86 ln 50. Close the parentheses. How much is going to be? 236.43. They ask you to round to the nearest tenth. So that means I need to take only one number. Check this number less than 5. So you're not going to add 1 on the 4. This number 3 is less than 5. So the result is going to be f to the 50 equal 236.4. That's it for this example. So let's do, if you need time to write down these, let me know. Change of base theorem. Let's write down the theorem here. The change of base theorem. If you have log to the base a to the x, this is the rule. How I'm going to find the result? It's easy. I'm going to use this rule. I'm going to say log to the x over log to the a. That means the base here is 10, the base here is 10. I don't have to worry about the base. Or I can, so this is the rule. Or I can say ln to the x over ln to the a. But I'm going to use always this rule because they're going to ask you to use the change of base theorem. For example, they give you find log to the base 9, 62.74. Of course, you're going to use the calculator here, but sometimes they're going to ask you to use the change of base theorem. So this one is going to be log to the x, which is this number here, 62.74, divided by log to this number, which is 9. So on the calculator, you're just going to say log this number divided by log this number is going to be the result. So it's going to be equal let's see. There's the calculator. I'm just going to say log to this number, log to 62.74 is going to be 1.7975 over log to the 9 is going to be 0.9542. Now divide this one by this one. The result is going to be 1.8837. Sometimes they're just going to ask you to write down using this, the base of theorem, the change of base theorem, which is until this step. And if they ask you to find the result, you have to go ahead and use the calculator. Here's another example about the change of base theorem. Find log to the base 2 to the 0.6. So it's going to be, this is the x, this is the base. So it's going to be log to the x, which is 0.6, divided by log to the 2. Also, you can use the calculator right away without finding how much log to the 0.6. How? Let me show you. You're just gonna plug in log to 0.6, close the parentheses, divide by log to the 2, close the parentheses. So the result is going to be negative 0.73695. 696. So it's up to you how we're gonna find it. It's right. This is the important step by using the change of base theorem.